On this channel, we've repeatedly found that nature not only reveals functional structures, but often also profound beauty and aesthetics. This interplay of order and grace runs through microscopic worlds just as it does through the vastness of the cosmos. Another fascinating idea that picks up on this connection between science and beauty is the concept of the harmony of the spheres. The idea that even the movements of seemingly randomly formed celestial bodies follow a hidden order. Even though there are different positions on this, let's take a look at what it's all about. The planets don't just fly around randomly in space. The first realization is that they are on the same plane. Each planet orbits the Sun in an elliptical path with its own speed and at the same time rotates on its own axis with its own rotational speed. The Earth rotates once on its own axis in 24 hours and orbits the Sun in about 365 days. To illustrate the differences, here's an example with Venus. A Venus year, that is, the time it takes to orbit the Sun, lasts about 225 Earth days. A Venus day, that is, one rotation on its own axis, is about 243 Earth days. A solar day, that is, from sunrise to sunrise, is about 117 Earth days. Why a solar day is not the same as a Venus day, like it is on Earth, has to do with the rotation and the orbit around the Sun. So we can see that it can be very different from what we know on Earth. The concept of the harmony of the spheres is not new at all and goes back as far as 570 before Christ to Pythagoras. He believed in a special order in the cosmos, stemming from his fascination with the beautiful numerical ratios found in harmonious sounds. For example, you pluck a whole string and the fundamental tone of 220 Hz sounds. If you halve the string, it vibrates at 440 Hz, which is a ratio of 1 to 2. In music, that's exactly 1 octave higher and sounds harmonious together. For example, a 3-2 ratio produces a fifth, a fundamental musical interval. So, why do numerical ratios ultimately harmonize with our brain, which defines a sound as pleasant? With this information, it's even more interesting to consider what effects this pleasant sound might have on our brain. The core claim is that the aesthetics of the world are apparently somehow intertwined with our existence. Based on that, Pythagoras believed that celestial bodies are also subject to a certain harmony. Johannes Kepler in the 17th century was the one who then brought the whole thing to a scientific level. As the discoverer of the laws of planetary motion, he investigated if such harmony truly exists. He discovered that the orbits are actually ellipses and examined the velocity ratios for harmony. He is known for discovering the laws of planetary motion, but people still criticize his ideas about the harmony of the spheres. He saw much more in creation than just the dry laws of physics. But was he right? Today, with our technical means, we can take the whole thing to a new level again, says the researcher Hartmut. He has tried to illustrate this harmony using computer simulations. He did this in his book, The Signature of the Spheres. For example, he compares the Earth with Venus and looks at the so-called conjunctions. These are the points where the Sun is aligned with these two planets and they have the shortest possible distance to each other. These conjunctions over time are now connected with each other. After 8 years, until this conjunction occurs again at exactly the same spot, a total of 5 conjunctions are formed, which, when connected, create a pentagram. The pattern repeats every 8 years with minor variations. Because of this small deviation of 2 days, it doesn't occur exactly at the same spot, but slightly shifted. In other words, there is an overarching rhythm. Now you can also look at the pentagram as a single object. It also rotates once around itself, which takes over 1,000 years. And here, an important general concept is revealed. Namely, that by using the passage of time, you can look at overarching processes to reveal further connections. If someone only knew the molecular composition of water, that wouldn't necessarily mean they really know what water is. Every few days, he draws a straight line between the two planets. Look at the pattern that emerges from this approach. This pattern emerges when he draws a connecting line between Venus and Earth every time a Venus day passes, which is every 117 days. If you look at Jupiter and Uranus and again draw the straight lines between them, considering the conjunctions as in our first example, that is, the points where they are closest together, and connect these points, a hexagon is formed. Do the most fundamental shapes also repeat themselves in the macrocosm? Hartmut also considers 3 planets at once. For example, he adds Mars to Jupiter and Uranus. At the moments of conjunction between Mars and Jupiter, he draws a straight line between Jupiter and Uranus. This time, it takes about 1,000 years for a beautiful figure to emerge. Here is the image from Mars, seen from a Venus-centered perspective during the Venus-Neptune conjunction. And here is Mars from a Venus-centered perspective during the Venus-Earth conjunction. Earth from a Venus-centered perspective in conjunction with Pluto. You can see that a wide variety of parameter constellations were chosen. So, what do we do with this discovery now? Doesn't this area have potential? It's very rarely talked about. Does it work in other solar systems too? Every figure, every numerical connection, the entire system of harmony, and the orbit of the stars must appear to anyone who is properly instructed as a single, unified, great whole. And it will appear to him that way as long as he, following this guidance, constantly keeps this one goal in mind. For every attentive observer, it will be clear that a natural bond connects all these objects. Does such a common bond exist? Hartmut describes seemingly harmonious patterns in the movements of the planets in his theory of the harmony of the spheres, and interprets these as an expression of a deeper cosmic order. His calculations and representations are mathematically correct, but they are met with criticism in the scientific community. The main criticism is the selective choice of data, known as cherry-picking. Only those planetary relationships and time periods that produce particularly aesthetic patterns are considered. It is also criticized that his theory does not make any empirically testable predictions. A fundamental criterion of scientific models. The aesthetic assessment of patterns is considered subjective and culturally influenced, even when resembling basic forms. Some experts see Worm's work more as a philosophical, esoteric, interpretive model than a scientific theory. While the images are fascinating, his interpretation is still controversial. I am seized by an indescribable rapture at the divine spectacle of celestial harmony. For here we see how God, like a human architect, approached the foundation of the world according to order and rule. Johannes Kepler. What drives a researcher to do research? Someone who is motivated to see creation will see it everywhere. Hartmut has likely discovered very intriguing connections. As always, interpretation lies in the eye of the beholder.